important thing. Doppler's effect is not an actual change in the frequency of the source. I want to be very, very specific in this. Doppler's effect is not the actual change in frequency, because whatever the noisemaker is doing, the noisemaker is doing. That's not going to change. It is just the effect due to the motion of the source and or the observer, right? That's why it's not called a frequency change. It's called the apparent frequency shift or the apparent change. Does that make sense? It will go back to the original source frequency as soon as either of those two things stop moving. Because the source is not making any more different sound than it was before. It's the same sound that it's making. And this effect always happens if the speed of the source is much smaller than the actual speed of the wave. Okay, so for example, remember in our example here, what's the actual speed of the source? 50. But what is the frequency of the wave? 344, right? The sound traveled at 344. You will see a change in it. But if you start going at Mach speed, that change becomes a sonic boom. You know, like when you see those TV things, if the waves bunch up and if it tries to go faster than the speed of sound, like for example, your airplanes try to go faster than the speed of sound. So the faster you go, the more the waves bunch up in front of you. The more the waves bunch up in front of you, the more resistance you'll feel from them. And there comes a point when you break through them, when you travel actually at the speed of sound, you will be crossing that barrier, and there'll be like a sonic boom that you will feel. And that sonic boom is actually what you hear. Now, people think that sonic boom only happens once and it's gone. That's actually not true. Every single one of these people down the line, this one, and this one, will all experience sonic boom as the plane passes by them. But once the plane has passed, this guy is now relaxed because he doesn't feel that anymore, right? Whereas this guy is still waiting. There's nothing there. So sonic boom actually happens because sound is a pressure wave. And this happens in a cone shaped behind the plane. So on the ground, that shape is called a hyperbola. And it depends on the height. The actual shape depends on how high the plane is. And remember this picture where we were saying that this person has already experienced the sonic boom, this person is experiencing it now, and this person hasn't even heard it yet. Every single one of these people, if there were people standing on this sonic boom, will experience it together, the boom. Whereas if there were people standing here, they would have experienced it a long time ago. And now it's just noise to them. Does that make sense? Yeah. That was fascinating the first time I realized that was what's going on. Like, oh yeah, that makes sense. And some of the applications of Doppler's effect include, the biggest one is when we were thinking about whether scientists were thinking about whether the universe is expanding or contracting. Do you know how we figured that out? Doppler's effect. Light is a very funny thing. So remember, light is a wave, and all the colors that you see in light, like all the way from red to green to orange, are basically frequencies, right? So every light has a particular frequency. So red light has longer wavelength and a lower frequency, whereas blue light has a higher frequency or a shorter wavelength. So when things come close to us, remember they bunch up? So we would see a blue light, because that has a shorter wavelength, like a smaller impact. But if things were going away from us, we would see a red light coming from those stars, right? Because they have a longer wavelength. And guess what we observed? We observed a red light. So we observed those stars to be red shifted, which could only mean that these stars are going away from us. So Doppler shift told us that the universe is actually expanding and not contracting. Right? So waves are fascinating because they behave exactly the same no matter what kind of a wave you have. Sound, light, water. You have a wave, it behaves exactly the same. And you've heard the word Doppler radar, remember on TV? Guess what they're doing? They're doing exactly the same thing. All they're doing is figuring out whether the thunderstorm is coming towards us or it's going away from us by how much the waves that are coming towards us are shifted, right? If it's going away from us, will the waves be longer or shorter? They're going away from us. What do I have to do to make the wave? Longer, right? And what about when they're coming close to us? Shorter, right? And that's what Doppler radars do.